Okay, so this is the average function f of x out of interval a b equals 1 divided by b minus a, the integral of b to a f of x dx. So for example, what we're going to do is we're going to integrate question 2 and question 4. So in question 2, what we're going to be asked to do, the a equals 1, b equals 4. So what we're going to get is the average value is going to be equal to 1 divided by 4 minus 1. The integral of 4 to 1 of f of x, which is going to be 3x squared minus 1 dx. Okay, so now when we integrate this, we're first of all going to get a third to begin, and then we're going to integrate this here. So when we integrate this, what we're going to get is when you integrate x squared, you get x cubed. Differentiate x cubed, you get 3x squared. So it's going to be x cubed minus x from 4 to 1. This third can go in here, because multiplying by third afterwards or including the third in the integral is the same thing. Okay, so what's going to happen next is we're now going to integrate this, and we're going to see what we get. So what we're going to get here is we're going to get 4 cubed minus 4 all over 3. Then we're going to have minus 1 cubed minus 1 all over 3. Now 1 cubed minus 1 all over 3 is 0. And then this 4 cubed minus 4 is going to be 64 minus 4 all over 3, which is going to be 60 over 3, which is going to equal 20. So the average value of this integral is 20. Okay, so that's the first one done. Now we're going to move on to question 4. So question 4 is the function e to the x. Okay, so once again the average value is going to be 1 divided by b minus a. So b is going to be 3, a is going to be 0. So it's going to be 3 minus 0. The integral of b, which is 3, a, which is 0. Then we're going to get f of x, which is going to be e to the x dx. Okay, and now we're going to get a third. The integral of, when you integrate e to the x, you get e to the x, and that's from 3 to 0. And then when we integrate this, what we're going to get is bring in the third. So we're going to have a 3 in there. We're about that, the third on the outside. Then what we're going to get is e to the 3 divided by 3 minus e to 0 all over 3. And that's going to be e to 3 over 3 minus a third. We factorize out a third, and the average value equals a third, e to the 3 minus 1. Okay, so that's the answer to questions 2 and 4. Now that 2 and 4 are done, we're going to move on to question 5. Okay, so question 5. Now, in question 5, what we have is a swimming pool is being drained such that the volume of water remaining after t minutes is given by the volume is 100 multiplied by 40 minus t to be squared meters cubed. What was the volume of water just as the draining began? So what we can deduce from this is, if I was to multiply out 40 minus t squared, okay, so if I said 40 minus t squared, if I was to multiply that out, I was get 1600 minus 80t plus t squared. The plus t squared makes it a u-shaped function. So if I was to just quickly have a quick sketch of this graph, okay, so what I was to do is just put down f of x, go into your table function, and I'll say f of x is 100 multiplied by 40 minus x squared, because x is going to be representing t, to be squared. And then I'm going to start it off at 0, and I'm going to go up in, I don't know, up to 100, let's say, because I haven't got a clue how far this should go up. I'm going to go up in steps of 10. And look what happens. Okay, so at the start, we're going to have the pool is 160,000 litres. Okay, or say 160,000 meters cubed. And then as time goes on, we can see it gets smaller and smaller. And we can see after 40 seconds, there's no volume left. And then it hits the bottom and goes back up again. So what we can see is this, that the function starts off at a really high value, comes down in a U-shaped form. Its minimum value is when it's empty, and then all of a sudden it'll go back up. That's if we're filling it. Okay, so what was the volume of the water just as draining began? As draining began, it's going to be 160,000. This is because t has to equal 0 just as it began. Okay. Now, after how long did it take to fully drain the pill? When did it go down to 0? 40 minutes. Okay. So that there equals 40 minutes. Now, another way to solve that 40-minute problem would have been to do this. When you say phi equals 0, when the volume of the pill is empty, so 0 equals 100, bracket 40 minus t squared. The 100 cancels, 0 equals 40 minus t squared. Now you can do this too, it's already done for you. So it's going to be 0 equals bracket 40 minus t, bracket 40 minus t. You solve it and you get t equals 40. Because you're going to get 40 minus t equals 0. Bring over the t equals 40, okay? What was the average volume of water in the pill while it was being drained? Okay, so while it was being drained. Well, what we know is the start of the interval is 0. The end of the interval is 40. And then we can go ahead and try and use our formula here. Okay? So what we're going to have is the A and B. A is going to be 0 and B is going to be 40. So it's going to be 1 over 40 minus 0, which is basically 1 over 40. So it's going to be 1 over 40 multiplied by the integral of 40 to 0, and that's going to be 100, bracket 40 minus t squared. Now what I'm going to do is I'm going to bring the 100 to the outside and divide 40 into 100. And we're going to get there is 2.5. So it's going to be 2.5, the integral from 40 to 0, and that should be the t at the end. So the 100's gone. I'm going to multiply it to 40 minus t, and I'm going to get 1600 minus 80t plus t squared dt. Now I'm going to integrate this, and when I integrate this I'm going to get 2.5 times the integral of, it's going to be 1600t. That's going to be t squared. So t squared, now put 40 in front of it, because when you differentiate t squared you get 2t. 2t times 40 is 80t, and then finally it's going to be a third t cubed. Okay, and the integral is going to be from 40 to 0. Okay, what I'm going to do next is I'm going to multiply everything in here by 2.5. Just want to get rid of that 2.5 so I don't have to deal with it later on. So you're going to get is 3200t. Oh, sorry, not 3200t, excuse me, it's going to be 3200 plus, it's going to be 4000t, because that's going to be 2.5. That one there is going to be minus 100t squared, and finally the last one's going to be 5 over 2 multiplied by a third. So we'll see what this is here. So 2.5 is 5 over 2, or what we just say is 2.5 multiplied by 1 over 3. We'll get there is 5 over 6. So plus 5 over 6 t cubed from 40 to 0. Now we only have to worry about the 40s. So the average value is going to be 4000 times 40 minus 1000 times 40 squared plus 5 over 6 times 40 cubed. Close the bracket there. It's all going to be minus 0 because there's a t in every one, so it's going to be 0 for the second part. So we're going to put this in the calculator, and we're going to get is 400 divided by 40, and then we're going to take away minus 100 times 40 squared. Then it's going to be plus 5 over 6 multiplied by 40 cubed. And so what we get here is 160,000 all divided by 3, which is the correct answer, or that there, 53,333 and 1/3. But I'm going to keep the answer as 160,000 over 3. And it's going to be measured in meters cubed. Okay, so that is question. That there is question 5 done. Now we're going to move on to question 6. Or sorry, question 7. So what's asked me first and foremost is to sketch the equation of the curve of y equals 4x minus x squared in the domain 0 less than x less than 4. So I'm just going to go straight into the table function here. Table function, then we're going to get a 4x minus x squared. And I'm going to go from 0 to 4. And I'll currently go up in 1. So we can see 0, 0, 1, 3, 2, 4, 3, 3, 4, 0. So what we know for a start is it's n-shaped. The reason why it's n-shaped is the minus x squared crosses at 0 and crosses at 4. So what we can just do is just put that shape in like that, n-shaped graph anyway, okay? Because what is the maximum value of y? Well, to get the maximum value of y is max is a turning point. So what you do is you get the slope, remember, of the graph is 0. So if the slope equals 0, this means that dy dx equals 0. So differentiate and we get 4 minus 2x equals 0. We're going to get 4 equals 2x, x equals 2. It's what you'd expect. The middle point, x equals 2, is the x value of the maximum point, but it's not actually the maximum. It's not the maximum value. The maximum value we then have to replace in 2. So 4 times 2 minus 2 squared, and the answer is going to be 4. So this point here is 2, 4. It's considered to be the maximum point, and the maximum value of y is 4. Okay, from a graph, write down the minimum value of y within the given domain. The minimum value of y is obviously going to be 0. Okay, so the minimum value of y is going to be 0 at this point here and this point here. From your graph, calculate the average value of y in the interval 0 to 4. Verify that the average value of y lies between its minimum and maximum values. Okay, so the minimum is 0 and the maximum value is 4. So let's do the maths here, right? So it's going to be 0, 4. A equals 0, B equals 4. So it's going to be 1 over 4 minus 0. We don't need the minus 0. So it's going to be 1 over 4. The integral of 4 to 0. And then we're going to integrate 4x minus x squared dx. Now, when we integrate this, we're going to get 1 over 4 bracket. Now this here is going to be 2x squared. That's going to be a third x cubed. And that's going to be from 4 to 0. I'm going to multiply in by this 4 now, just the way I like to do it. So I'm going to get x squared over 2. And then I'm going to get a quarter by a third is a 12th x3 from 4 to 0. The second interval is a 0, so we don't have to worry about that. So we're going to get 4 squared over 2 minus 1 over 12 4 cubed. So that's going to be a 16 divided by 2 is going to be 8 minus 64 over 12. So 8 minus 64 over 12. What we get there is 8 over 3. Okay? And average value is 8 over 3. And 8 over 3 is in between 0 to 4. Hence, the average value is in between the minimum and the maximum values. That's also verified as well. Okay, the last question is question 8. A temperature of T Celsius on a certain day at a time T hours relative to midday can be represented by the following function, where T equals 1 over 1600 by T to the power of 4 minus 450 T squared plus 50,625. What time is represented by T equals minus 8? Well, if T equals 0 is midday, so that one's going to be 10, that's going to be 8 AM, 6 AM, I'm going to say 4 AM in the morning. Okay, so it's going to be 4 AM or 0.400. Okay, calculate the average temperature during the day. Well, there's two intervals, I suppose. For the full day, your lower interval is this one here, and your upper interval is this one here. So if we have our formula from the last part, last question here, so we're looking for the average formula. So we're just going to use this here. Bring it to the next slide. Now, what we can see here is our B value is 12 and our A value is minus 12. So it's going to be 1 over B minus A, which is going to be 1 minus 12 minus minus 12, which is going to get me 1 over 24. 1 over 24, the integral of 12 to minus 12, this function here. This function here is going to be 1 over 1600 by t to the power 4 minus 450 t squared minus 5625 dt. Now, what I'm going to do here is I'm going to multiply 1 over 24 by 1 over 1600. I just want to get that out of the integration part. So it's going to be 1 over 24 multiplied by 1 over 1600. And what we get there is 1 over 38,400. So 1 over 38,400, the integral of 12 to minus 12, t4 minus 450 t squared plus 50,625 dt. I'm going to try and integrate this now. So when you integrate this, it's going to be 1 over 38,400. The integral of, let me see, so this is going to be a fifth t to the power 5. It's going to be minus 150 t cubed. And then it's simply, after that, it's going to be plus 50,625 t, all from 12 to minus 12. Now, you're looking at a very long sum here. So what I'm going to do is I'm just going to keep out the 1 over 38,400 to the end. So it's going to be 1 over 38,400, and that's going to be multiplied by whatever is in this green bracket. And what's going to be in this green bracket is this, okay? It's going to be 1 over 5, 12 to the power 5, minus 150, 12 to the power 3, plus 50,625 multiplied by 12. And that's going to be minus whatever's in this bracket, which is going to be a fifth, minus 12 to the power 5. Then it's going to be minus 150, minus 12 to the power 3, plus 50,625 to the power of multiplied by minus 12. Now, I'm going to have to put all this in the calculator. It's going to be very tricky, so it's going to be 1 over 5. 1 over 5, 12 to the 5. One over 5, 12 to the 5. Minus 150. Cubed plus 50,625 multiplied by 12. Just going to press the equal sign at this point. Alright, that's the equals part for that part there. Now we're going to take away the other part here, which is going to be in the brackets, going to be a fifth, 1 over 5. That's going to be minus 12. Minus 12 to the power 5. Minus 12 to the power 5, that's going to be minus 150. Minus 150. Minus 12 to the power 3. Minus 12 to the power 3. And finally, plus 50,625 multiplied by minus 12. Okay, press the equal sign there, and we can now see it's this number here. Now we have to divide this number by 38,400. So divide your answer here by 38,400, and we're looking at is 20.73. Calculate the average temperature during the day. Well, the average temperature during the day is 20.73. or 20.73 degrees, which can round up to 21 degrees. Okay, so that's that question done.